we're going to start with 4142. So here we've gone over how to find the equation of a linear function, like I feel like 100 times, where you do find the slope and then plug into point slope and solve for y. And so I don't feel like doing that this time. So instead, we're going to go to stat and then edit, and we're just going to put our 2 points in here. So my x values are 2 and 7, and my y values are 2 and 8. 2, 2, 7, 8. And then to figure out the equation of this line, I'm going to go stat, calc, linear regression. The calculator is going to figure out the equation of this line for me. The equation of this line is y equals 1.2x minus 0.4. So I am also going to have the calculator figure out the equation of the exponential curve between these 2 points. I'm going to do that by going to stat, calc, and if you scroll down, the first option off the screen is exponential regression. It's right there at 0. And so the exponential equation between those 2 points would be 1.1487 times 1.3195 to the x.
Here I was doing it the wrong way. I should have thought about that. I didn't.
Yeah, I mean, it's always an option. So like for the next one, I could do this one the same way as I just did that one. I'm going to do this one by hand though, just so that we can see it. Listen, ladies, doing it the long way is fine. There's nothing wrong with that. It's more math. It's better practice, but not 100% necessary.
Yeah.
So here, remember that the basic equation of an exponential function is y equals a times b to the x. And that a value is always my y-intercept. So if they give you the y-intercept, then they give you a. So here I know that a is 5. So what I have now is y equals 5 times b to the x. Is this the way you were doing it before?
Yeah.
And then I take x and y and I plug them in. So I'm going to say x is 3 and y is 135. B to the third. And then I solve for b. So I'm going to divide both sides by 5. And then take the cube root. So the cube root of 27 is 3. So that means b is 3. So if a is 5 and b is 3, they want me to use f of x. Then f of x equals 5 times 3 to the x. And again, if you don't want to do any of them by hand, you don't have to. You can always just put them in the calculator and find and have it calculate the regression between them for you. Okay. So I'm going to use the calculator for this next one. We'll go back to it. And what you're looking for here is we're gonna plug in, we're gonna put each table in, and then we'll know if it's linear or exponential if we get an r squared value of 1. And then we're also looking for r to either be 1 or -1. If you get an r of 1 or -1 and an r squared of 1, then it is definitely either linear or exponential. If you get anything else, it does not matter how close you are. If it is not this, then it's not. So let's see what I mean by that. Go to stat, edit, get rid of these. And then 1, 2, 3, 4, 60, 24, -8.8. Now this doesn't look linear to me because we know that in a linear function we should have a constant slope, so we should be going up or down by the same amount every time in my y's, especially if we're going up by the same amount every time in my x's. But let's check it. Calc, linear regression. And now if we look here, see how r is really close to -1 and r squared is really close to 1? It doesn't matter. If this is not 1 or -1 and this is not 1, then the answer is that this is not linear. Okay? So let's check exponential. Uh-oh. So an error tells me that it's definitely not exponential. The reason why I got this error is because the range of an exponential is always positive. So we can't have an exponential with a negative output, which is why this is saying that there's an error. So here, this one I'm going to say is neither. I have no idea what's happening in my house. I just heard my daughter shout, "No, Dada!" That can be anything, you know, at 2.
Yeah.
My
You
son's
just
at a
never
football
know.
game.
You get some peace and quiet.
Yeah, it's pretty quiet. Just Hank's snoring next to me.
Okay, so I'm going to do this again with the second table. Now, again, I'm reasonably sure that this is not linear because it does not have a constant slope, but let's check it anyway. Nope. Okay, not linear. Let's check exponential. Aha!
There you go.
So this one is exponential.
Nice.
And now I'm not going to bother checking this one because you see how it goes up by 1 and down by 20 every time. So this one is definitely linear. Now, I do want you to know that I don't expect you to be able to recognize these immediately. Like if it doesn't jump out at you, oh, hey, this is linear, and you wind up putting it in the calculator and checking, that's fine. Okay? But that one's definitely linear. That constant rate of change in my y's. Definitely linear. Okay, so for this finding the equation, I'm literally going to do the exact same thing I did on the second example. I'm just going to pull 2 points from this graph. Here I have the point 0.03, and here I have the point 0.16. And if you want to put this in stat calc, if you want to go put this in stat calc exponential regression, go crazy. I'll do it the long way this time. So a is 3, x is 1, y is 6. So that means 6 equals 3 times b to the 1. But we know that b to the 1 is just b. So if I divide both sides by 3, I would get b is 2. And so this is going to be k of a equals 3 times 2 to the, not x, to the a. And like I said, that's definitely the long way. So feel free to put it in the calculator. All right. These things, when we graph them, one of 4 things happens, and that is going to be based on my a value and my b value. So we're looking for a to either be positive or negative, and we're looking for b to either be greater than 1 or in between 0 and 1. So if you have a positive a and b is greater than 1, then your general shape looks like this. If you have a positive a and b is in between 0 and 1, then your general shape looks like this. If you have a negative a and b is greater than 1, then your general shape looks like this. And if you have a negative a and b is in between 0 and 1, then your general shape looks like this. Those are the 4 possibilities for this curve. And so here, if we think about this in terms of our transformation rules, this would be my h value and this would be my k value. I don't know if you remember that from transformations, where the h is what's in the parentheses, k is what's on the outside. And so when we're looking at these, if you're in this situation, then your left-hand end behavior, this over here is always whatever that k value is. And this is infinity. Here, your left hand is infinity and your right hand is k. And here your end behavior is that your left hand is k again, but your right hand is negative infinity. And here it's negative infinity on the left and k on the right. So if we're looking at this one, which is a negative leading with a negative a and a b value greater than 1, that means that this is what my graph is going to look like. So on the left side, as t goes to negative infinity, that means it's going to go this way. It's going to approach this k value right here. And on the right side, as t goes to the right, your y values are going to go down. So that's a handy little chart to have. You could always graph this too. Like, I think I still have it in my calculator. If we graph it, you'll see that it is this general shape. And then we know that that 2 shifts it up 2. So our asymptote is normally at 0, and then that plus 2 shifted it up 2, which is why we're approaching 2 on this side. Now, I know I said that I didn't think that we had another day where we did more than one section, but I lied, because here we are. So the other thing that we're going to talk about tonight are logarithms. Logarithms are the inverses of exponentials. So if we have a log with base b of x equals y, that would be the exact same as saying y to the b equals x. No, b to the y equals x. Oof, it's late. B to the y equals x. So really, I'm asking you, what exponent, 3 to what is 1 over 81? What would I raise 3 to get to 1 over 81? Well, 3 to the 4th is 81, and in order to get the reciprocal, you make the exponent negative. So 3 to the negative 4 is 1 over 81. Five to what power is 1? Well, any base to the 0 power is 1. Now, if you hate that, use the calculator. So if you have a TI-84 like I do, you can press the math button and then scroll down till you get to log base. Choose that. And this would be 4 of the square root of 64. Now they're asking for exact values, which means they want fractions. So remember, math enter, I'll turn a decimal into a fraction. So that one is 3/2. Now, if you have a TI-83, then you need to use this log button that you have right here. You don't have the log base option in math. So you would put that in as the log of this number. So the log of the square root of 64. Log of the square root of 64. Divided by the log of the base number. And so I get the same thing either way. So then this one is 3/2. And since logarithms and exponentials are inverses, this 8 to the log base 8 cancels, and I would be left with just a 3. Now, ln is the natural log and that is the log with base e. So log with base e is the same as the natural log, and that means that e and ln are inverses. So here, this e and this ln will cancel each other and leave you with just a negative 11, just a 5, just a square root of 3. And now for this last one, just like up above on the very first problem on this page, I said that the negative exponent is how you take the reciprocal. So this one would be negative 5, because this would be the same as the ln of e to the negative 5. That negative means to take the reciprocal. But again, if you're not good at those rules, if you don't remember them, just put them in the calculator. Now for the conversions, I'm going to use this that I have right here. So 4 to the y equals a is the same as saying log with base 4 of a equals y. E to the a equals c is the same as saying log with base e, but we just said log with base e is the natural log. Log with base e of c equals a. And so then for this one, it would be c to the b minus 1 equals p minus 6. So once you get the hang of those conversions, they're going to go really quick. All right. Now, when you are trying to find the inverse of any function, it's 3 steps. Your first step is to change f of x to y. And then swap the places of your x and your y. And then solve for y. So the first thing I'm going to do is add this 3 over. Now, at this point, in order to get the y by itself, I'm going to have to take the log. So I'm going to do the log with base 5 of x plus 3 equals y plus 2. So anytime you're trying to get an exponent by itself, or you're solving for something in an exponent, convert that thing into log form. Right? And then the last step is going to be to subtract this 2. That's going to be on the outside of the parentheses. And that is your inverse. So when you're thinking about just your basic y equals log of x, this function has a domain of only the positives and a range of all real numbers. Negative infinity to positive infinity. And so no matter what transformations you apply, the range will always be all real numbers. The domain, however, will be affected by horizontal shifts. So here we have a horizontal shift in the graph. This means that it will move to the left 9 units. And so that means that the domain will shift left 9 units as well. So from 0 to infinity, back 9 to negative 9 to infinity. Now, logarithms always have a vertical asymptote. So when we're dealing with logs, this is always going to be vertical. And it is always at this value. So this one has a vertical asymptote at x equals negative 9. Right, and then last but not least for these, when we're thinking about the properties of these graphs, these questions are going to ask you about 3 points that you need. And so it's going to be the same 3 basic points every time. The points are always 1, 0. This b value, 1. And then 1 over b, -1. So it's always those 3 points. So here my 3 points would be 1, 0, 4.5, 1. And then my last point is, well, what is 1 over 4.5? Okay, so it's always 1, 0, b1, 1 over b -1.
That really explains a lot. I was struggling with that for a little bit.
Yeah, and the reason why it's 1 over b is because we said that that -1 means to take the reciprocal when we're doing exponents, right?
Yeah, and I was thinking divide, and when you go up, it's times, and when you go down, it's divide.
Yeah.
But it kind of confused me with the video lesson.
Well, the whole point of me being here is to unconfuse you.
Thank you.
I was telling the class before you guys that, to me, it is Andy's job to really get into the theory behind why all of this is, and that it is my job to explain to you how all of that theory applies to your homework. If that makes sense. So he does the hard stuff in the videos, and then I come in here and I'm like, hey, remember when he said this? Well, this is how you do it on your homework. So now if we're dealing with an ln, I just want you to remember that your base is e. So with every ln, your points will be 1, 0, E1, but what is the value of E? Because they don't want E, they want a decimal point, right? So E, so round that to 4. So that's 7183. Oop, that's 1. And then we need the reciprocal of that. So take the reciprocal of it. Nope, 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 nope. That's my fault. I keep on pressing the wrong thing. Insert, there we go. Okay, so then .3679, -1. And now I want you to make a note for yourself that it is these 3 points for every natural log. So it doesn't matter what's happening to your natural log. It doesn't matter what your shifts are, horizontal, vertical. If you have an ln, these are the 3 points they want every time. Okay, now if they give you any other log, then you need to use that base value that they give you. But since every natural log has a base of e, then every natural log is going to start with these same 3 points. Okay, now when they're asking you for your new origin, they're asking you what your transformation will be. So this one goes left 4.6 and up 0.5. That's where those numbers come from. And then this is always vertical. And then my vertical asymptote here would be t equals, and then since this is a left 4.6, it would be -4.6.